Okay, so sorry, I'm starting here just a few minutes in. We just missed just a little bit, but you get the gist of today. So, do we get a half reaction written? I mean, the equation written based on these half reactions.
Yes.
Okay? So, Sydney, what you get?
I got 3 Ag plus aqueous plus Cr solid yields Cr3 plus aqueous plus 3 Ag solid.
Okay, very good. Now, how did you know to start with chromium solid and not Cr3 plus?
Because that is what's being oxidized, so it needs to lose electrons.
Lose, and it's going to go the other direction. Only one of these two is going to go left to right. Whichever one's getting, these are all reduction potentials, but everything can't get reduced. For every one thing that gets reduced, something else has to get oxidized. What loses electrons has to find electrons. So the thing that's being reduced goes left to right. The thing being oxidized is going to go right to left. Okay? So, why 3? What's the purpose, of the 3 in front of the AG?
Balance the charges.
Balance the charges, because it's +1 and +3. So if the question like on our mock exam asks for how many electrons are being transferred, it's going to be 3 moles of electrons transferred in this reaction. Total. Now, we haven't learned how to do 3 yet, but we're going to learn right now. Okay? This equation is given on your equation sheet. Now, this was also on your mock exam. Delta G is equal to negative NF E cell. Okay? N equals moles of electrons transferred. F is called a Faraday, kind of like what today is not. Is equal to 96,485.
Yep. 96,485.
Okay? Coulombs per mole of electrons. Coulombs is a measure of electrical charge. That's what Robert Millikan was able to find, the actual charge on an individual electron, and it's measured in coulombs. When you have a mole of electrons and you add all of the charge together for 1 mole, 6.02 times 10 to the 23rd electrons, it's this much charge total. So this is the charge, total amount of charge on 1 mole of electrons. Okay, it's a constant now because the charge on electron doesn't change. The mole is always the same number, so this number is always constant. And then E cell, we know what that is equal to cell potential. So we just calculated delta G is equal to negative. What's N going to be in this equation?
-3.
Well, it's going to be 3, so it's going to be negative times 3 times 96,485 times my E cell. And what do we calculate the E cell to be? Negative, well, it's 1.54, right? So even if you didn't get the other part right, you could still do this one. So somebody do this on a calculator for me, please.
Okay. You're just gonna steal mine like that?
The stealing chain reaction.
Oh, it is. -445,760.7.
Negative 445.
5760.
2 5s?
No, just 445,760.7.
Okay? Now, listen. This was a question on the mock exam. You just write that, you do not get any points. No, you have to have a unit. It's going to come out either in joules or in kilojoules. This is joules. A volt is defined as joules per coulomb, I think is what it is. Okay? And the coulombs cancel out, and you end up with joules. So this answer, delta G, we know delta G is always either going to be joules or kilojoules. This comes out when you do this is the big number. This is always joules. Always. Now you could say it as negative 446 kilojoules, and then they always use that per mole reaction if you want to put that. But if you just said joules or kilojoules, and we were all as teachers saying, oh man, I can't believe, but because there's two answers on the rubric, it's either joules or kilojoules, they give both answers, you have to specify your unit to get the point. It's an easy point. Okay? You gotta specify the unit. Delta G is always, when it's the big number, delta G, when you're doing most of this, it always comes out in joules, change it to kilojoules. Okay, if it's a big number like this, it's joules. If it's, if it's more like this, it's gonna be kilojoules. Okay, but this equation always gives delta G in joules.
Was delta G in kilojoules for the delta H?
But we had to change it because S was in joules and H was in kilojoules, so you had to change one or the other to get the right unit. Okay? So, delta G, this is just plugging into the equation. This is on your equation sheet. You don't have to memorize it, so that when you need to, go back and look on your equation sheet when you're looking at what is delta G in an electrochemistry problem, it's going to be that. Okay?
Does it tell us the Faraday number?
The Faraday is given on the equation sheet as well. You never have to memorize any equation or any formula or any constants, because they're all given. Okay, here's 2019. Here's 2019. Now, just for kicks and giggles, just for fun, let's look at A. The molecular formulas of diatomic bromine, chlorine, fluorine, and iodine are written below. Circle the formula of the molecule that has the longest bond length. Justify your choice in terms of atomic structure. Pick an answer, don't say it out. How would you justify it? Jeremy, what do you think?
BR2 because it has the greatest electron-electron repulsive forces.
Why would it have the greatest electron-electron repulsive forces?
Because its atomic radius is the greatest, so the proton.
Why are you saying that bromine's atomic radius is the greatest? When you're looking here, fluorine, chlorine, bromine, and iodine.
I thought it's H. It looks like an H.
That's an I.
Do you need glasses?
Yes. Hey, test taking.
Then I.
Test taking. They give you a list like this. It's either the first one or the last one. Top or the bottom.
And then iodine.
Okay? But it's not electron-electron repulsions, it's because,
More energy.
well, just simpler than that. Iodine has a bigger atomic radius, therefore the bond between the two is going to be the longest. And it's just, of the four, iodine is going to have the largest radius, therefore I2 is going to have the longest bond length. Your short answer responses only need to be 1 to 2 sentences, but they need to be full, okay? Sometimes I say that and you guys don't write enough, but other times if you say too much, okay? It has nothing to do with electron-electron repulsion, all strictly atomic radius. Okay, the bigger the atomic radius, the longer the bond length is going to be. All right, so now here, totally unrelated to A is part B. I see this. A chemistry teacher wants to prepare bromine. The teacher has access to the following three reagents, and they're given NaBr, Cl2, and I2. Using the data in the table above, write the balanced equation for the thermodynamically favorable reaction that will produce bromine. So if we want to produce bromine, what equation on the three there produces bromine? The top one, but doing what? Going backwards, right?
Yeah.
So what does that mean about that?
It's gonna be negative.
If I want to go this way, am I being reduced or oxidized? Oxidized. I want the Br minus to be oxidized. And I want which one of these two then do I pick?
No idea.
CL2,
Why?
Good question.
because the E cell
How do we know which one's going to be reduced, which one's going to be oxidized?
Bigger one's
The
gonna be
bigger one. So if you put in a Br minus and I2, is the I2 going to be able to get reduced in the presence of bromine? No, because it's the lesser E cell. The higher E cell, the more positive E cell is the one that gets reduced. So what do I need to put in with what? Come back here. We have these three things. Well, actually, we don't even need to worry. This is a clue right here. You don't even have Br2. Okay? So what am I putting it with what? Okay, so have we decided that chlorine's the one I want to mix with it, right? So I want chlorine, but what is my other starting product? Starting reactant. What did I say I'm going to make? I need to make this, right? Well, what am I going to start with? 2 Br minuses. So it's going to be Cl2. Oh, my eraser's not doing a very good job. This old crusty one does better. So I'm going to go Cl2 plus 2 Br minuses. And what's that going to make? Br2, and it doesn't give a state, plus 2 Cl minuses. And that would have to be aqueous, but states aren't important. You don't have to put states. Does everybody see how to get that? We have to break it down. A chemistry teacher wants to prepare Br2, so I want to make that. So if I'm going to make this, I have to go this way in my reaction, which means it's going to get oxidized. Left to right is reduced, right to left is oxidized. Everything is always written as a reduction potential. So, since I want this to be oxidized, the thing that's got to be reduced has to have a higher E cell than this one. So the only one that's higher is the chlorine. So as a result, the chlorine is the one I'm going to get reduced. It's going to go this way. This one's going to go this way. Now it's already 2 to 2, so we don't need any coefficients. And the electrons cancel out. Are you seeing that? Okay, now what does thermodynamically favorable have to do with this? Which means, what about E?
It's positive.
Delta G is equal to negative NFE. What must be the sign of E if delta G is going to be negative? Positive. And a positive E cell is your thermodynamically favored. A K greater than 1, a positive E cell, and a negative delta G all indicate spontaneous or thermodynamically favorable. Okay? So G is the only one that's negative. K is greater than 1, E is positive for thermodynamically favorable. Okay? So justify the reaction as thermodynamically favorable by calculating the value of E for the reaction. So what would E be? It's gonna be, that's right, 1.36 minus 1.07 is equal to,
0.29.
now, by calculating this, but let's say they wanted to explain it. You would just say, because E cell is positive, that makes the reaction thermodynamically favorable. That means, that means the reaction is thermodynamically favorable. Because E cell is positive, the reaction is thermodynamically favorable as written. Okay, this, it's kind of the same thing over and over again. I like this unit in that the math isn't real extreme. And notice again, we're never multiplying in our E cell reaction, we're never multiplying by coefficients. It's an intensive property. It doesn't matter how many you have, the voltage is always going to be the same. All right. So now let's look at the one assigned. It might make a little bit more sense now. Hopefully. This is the one that I gave to you kind of. See if you can see with this.
No, that's weird. Wait 1 minute. I can see.
I need my glasses back.
No,
Do
you're
it.
good.
Do you have negative eyesight?
I don't know.
Okay. Now, once again, just for fun, just for review, let's look at D. D doesn't have anything to do with electrochemistry. That's kind of the way these AP problems are. They just kind of mix and match concepts as you go. So they're never an electrochemistry problem or a stoichiometry problem or a gas law problem. They're chemistry problems. They throw it all in there, okay? So explain why I2 is a solid, and this goes on with a previous part of the question. This is just part D. Bromine is, I2 is a solid, but bromine is a liquid. Your explanation should clearly reference the types and relative strengths of the intermolecular forces present in each substance. Take 2 minutes and think of an answer, maybe even try writing an answer down. Did you guys already do that? You did, D? Okay. Well then, did everybody write one down? I see a lot of people writing now. As you're finishing writing, another tidbit that kind of came out of yesterday. The teachers, the powers that be, Danny, don't like for students to refer to IMFs as bonds, even though we call it a hydrogen bond, okay? They were getting all bent out of shape that, you know, that the intermolecular forces aren't bonds. Well, they're attractions. So they want you to kind of use the term more strongly attracted, okay? But, or the relative strengths of the intermolecular forces, one is more strongly attracted than the other. Not that the bond is stronger, although to me, if the term is hydrogen bond, then you can use the term bond. And I don't think as an AP reader, you would lose points for not being a bond, but they were making a big deal about it yesterday. Okay, so I'm just throwing that out there. So intermolecular forces are the attractions between the molecules. The covalent bonds and ionic bonds are the actual bonds holding the atoms together in the molecule. All right, Alex, what you think? Why is iodine a solid and bromine a liquid?
Because BR2 has weaker intermolecular forces than I2.
Okay, but now it says, she clearly referenced the types and relative strength. So what's the only type of attractive force between each of these molecules? Okay, how did we know that?
Because they're covalently bonded.
Because they're covalently bonded. They're non-polar covalent. So we need to say specifically, you have to say London dispersion force. So you can abbreviate LDS. Okay? Why does bromine have weaker, let's say it the other way, why are iodines LDFs stronger than BR2s? Somebody else.
Iodine's electron cloud is bigger.
Electron cloud is bigger, making it more polarizable, causing its LDFs to be stronger than bromines. Thus, it's a solid at room temperature, whereas bromine would be a liquid. It's electron cloud. Don't say that bromine is bigger. Okay? That's what we want to say. Bromine is bigger. Bromine, well, don't say iodine is bigger, because bromine's not bigger. Never say that. Okay? Iodine has a larger electron cloud than bromine. I2 has a larger electron cloud than Br2. Therefore, and another thing that was brought up a lot, don't use pronouns. Don't use it. Okay? Because we don't always know what it refers to. So, I2 has a larger electron cloud than Br2, therefore, I2 has stronger, I2 is more polarizable than Br2, so it has stronger LDFs, causing it to be a solid versus Br2 a liquid. All right? So be specific, try not to use pronouns. All right, so that doesn't have anything to do with electrochemistry. Good review though. Again, any diatomic molecule is always going to be, first off, it gives you a clue. Intermolecular forces tells me that it's covalent. If it's ionic, we're going to be dealing with Coulomb's law, positive to negative. You know, you don't have IMFs with ionic or metallic or covalent network. You only have IMFs with covalent. Anything that's diatomic, the difference in electronegativity is 0, so we automatically know it's nonpolar. Right? Okay. While cleaning up after the experiment, the student wishes to dispose of the unused I2 in a responsible manner. The student decides to convert the I2 to I-. The student has access to 3 solutions and the standard table, reduction table below. What should they mix together? Take 2 to 3 minutes. Think about this. What should they mix together? How do you know? And then write the balanced equation for it. Can you see a trend in the questions? Hopefully this is going to be a little bit easier now based upon what we've already done. Okay? So don't just sit there. Let's go ahead and try to come up with an answer. Write something down. Be an active learner. Don't be passive. I want on the right or one on the left? I know, but which one on the right? Which one are you gonna start with? Right? Or left of zero? Oh. I have that. I have that down here.
Our relationship is
Okay, so the question tells you which solution should the student add to I2 to reduce it to I minus. So we know we want the I2 reduced. So what does that mean about the other substance? It needs to be oxidized. Which one will be oxidized by the iodine? And how do you know? Okay, so this equation is the one that we want to be oxidized, right? So which way is this reaction going to go? Right to left. It's oxidized, it's going this way. You're all It wants to go this way. So what do we start with? Which one got circled down here? This one. Because you want to go this way. We want to go this way. Okay? The oxidized starts going the other way. So you're going to mix this. Because this one's already oxidized. Okay? So that's the thing on these, is that the reduced goes left to right, but the oxidized goes right to left. So you start with the oxidized. The start on the right side. Now, therefore, now again it's nice that it's 2 electrons, so that's nice and balanced already. So I know then that I want to start with I2 solid plus what? 2O. And put the darn charges on there. Don't just write S2O3. Okay? These are net ionic equations. And it's going to go to 2I minus, and I think this is aqueous, isn't it? Yeah. Plus S4O6. 2 minus. Yes, ma'am.
So when we're like justifying our answer, we would say, I2 needs to be reduced, so we'll use, the solution with
The lower
E
E cell.
And then.
Okay, circle the answer below, justify your answer, including a calculation for E cell. So you calculate E cell, that's the biggest justification, okay? And then you say, this would be the only one to give a positive or a thermodynamically favorable reaction. You could also say, you know, the S2O3 is the only one that would be oxidized by the I2. But so our E cell then is simply going to be our 0.54 minus, is it a negative positive, 0.08. So it's going to equal 0.46 volts. Okay? I mean, this is 2 or 3 questions very similar to one another as far as how they're asking the E cell questions.
So really, they've only got one question, and they're just reworking it.
But notice how it's important to write the balanced equation, the ionic equation. They're asking that every time. They're asking how to calculate E cell every time. Then, you know, they might give a picture of a diagram, different things. Okay? Yes, sir.
Why would it not be, why is it sort of
Okay, because it's got a greater E cell, so that means it's gonna wanna go this way, so it's gonna cause the I minus to get oxidized.
But it's gonna be negative if you go the other way.
But you can't make it go the other way. Okay, so, well, if we made this go the other way, if we did this going this way, then it's gonna be 0.54 minus a 0.68, which is gonna give me a negative E cell, which is not thermodynamically favorable. But wait! There's Ugh. Okay, back to the mock exam.
He did. It was also a semester, so you want to be.
I
don't know who they are at all, but I know what they are.
Okay, so, listen. Hey, here's another thing, another tidbit. And listen, another tidbit for you. Little test taking. See these things right here? These are called lines. They put these lines because that's where they want the answers to go. Okay, they don't want to go up in here. They don't want to go down at the bottom in the blank space. They put the lines here because that's where they want the answers. Put your answers on the lines.
Did someone not?
Oh, a lot of people did. They all crammed it in
What
here.
about us?
In our class?
I can't remember.
I don't think.
I skimmed through y'all's and then got depressed and threw them in my, I mean, Do what?
It's not in the lines, they're not grading it.
Now, they are grading it if it's anywhere on the paper. It's just a pain.
All of my random notes there.
No, now you gotta, we have to look at everything on the paper, and sometimes even if we do different things, for instance, if you did oxidation states up here, okay, we would use that as part of your answer down here. Because this particular question now says, how many moles of electrons are transferred? But it says, justify your answer in terms of the balanced equation and the change in oxidation number of oxygen. Okay? So, some of y'all just, I mean, well, obviously it's how many electrons, well, a lot of people put 2, but 4 electrons are going to get transferred. It says it right here. When you go 2, why did they multiply this by 2?
Charge.
Balance the charge. So they had to, this one's going in reverse. This is the higher oxidation state, the higher E cell. So it's being reduced, this is being oxidized, so it's going right to left. NADH going to NAD plus. I have no idea what that is, it doesn't matter. I don't need to know what those things are, that's all just superfluous information. But I know that this one's going that way, this one's going here, I multiply by 2, so I have 4 electrons. But why in terms of oxygen? What is the oxidation state of oxygen in O2?
0.
What is it in water?
2.
-2, but that's on each oxygen, right? So each oxygen is going from 0 to -2, but how many oxygens do you have in a mole of O2?
2.
2. So how many electrons total are transferred? 4. That was your justification. Okay? We have to be able to do our oxidation states. We spent some time the other day going through oxidation states. Okay? So each oxygen is going from -2 to 0, from 0 to -2. But you have 2 oxygens per mole. Therefore, it's 4 electrons total being transferred.
What is the balanced equation that we're supposed to be writing here?
The balanced equation is already here.
Yeah, it says justify your answer in terms of.
In terms of the in terms of the balanced equation and the change in oxidation states. So the whole point is that we're getting 2 moles of oxygen being changed. Oh, losing track of where I am. Now, how do we do, the next one is calculate E cell. So most of y'all got this, but how do you calculate E cell?
Reduction.
So it's just 0.815 minus the negative 0.32, is that 0? I can't see, I have my arrow on it.
I'm guessing it's a 9.
Is it a 0 or 9? How many votes 0?
Zero.
How many vote 9? And by the way, who won, how are you gonna spell your name?
I'll tell you by the end of Friday.
Oh,
Oh, trade.
it's still open?
Yeah.
Oh, I deleted it.
Thanks.
I'll go back, I'll undelete it and figure it out, I'll vote. Hey, but by the way, that's awesome that you're gonna.
Yeah. I can't vote in midterms, but
Yes.
I'm waiting for it.
Okay, so we're all good on E red minus E ox, right?
Yeah.
And then the next one is calculate delta G. So what did E cell come out to?
1.3.
Okay, now in terms of sig figs, it's 0.815 minus a negative 0.320. So how many decimal places does each one have? 3, right? Therefore, we want to keep the 3 decimal. Remember, adding and subtracting for sig figs, adding and subtracting on sig figs, we keep decimal points. So that turns out to equal 1.135?
Yes.
Okay, and that's volts. Now, if you didn't put a unit on that one, there's only one potential answer for that, so they didn't take off for not having units. They also didn't even take off for you not showing work on that one, but I don't ever recommend you not showing work. But it's simple subtraction, so they kind of let it go.
You said if you don't put the units on a problem that has 2 answers, will they take off half or will they?
No, it's at 1 point, it's all or nothing. Okay, so put units. All right, so that's my E cell. So the part C on this one was calculate delta G. So what do we plug in? What's N? 4. F is always 96,485. And my E cell is 1.135. Somebody give me an answer.
Negative 4.38
10 negative 5?
Yes, joules.
And that's got to be joules. If you didn't put that joules, you didn't get your point. I know, it stinks.
How's it negative to not negative?
Because that negative, there's a negative right here.
Just 5. Just 5.
The formula has a negative sign in front.
Then to the negative 5, it's just a 5.
Oh,
I got used to saying
That's what
It's just a really
yeah, no, it's a real big number. And so it's gonna be 438 kilojoules. Okay? You can put either one. You have to have the negative sign. You have to have the unit. I think there's one more thing I want to show you. Who's playing the trumpet?
Sam can play the trumpet.
Is Sam in this classroom right
Who is playing the trumpet?
Play the trumpet. We said who's playing the trumpet?
Garen plays trumpet.
I
You
play
play-
piccolo.
Garen's
What?
play trumpet.
I play piccolo.
You're the pipe piper.
It's a flute, but
Yeah,
It's the small little flute,
About the
the
size of
one
your
that's
pickle.
smaller than my hand.
So you're the piper, like the pipe piper.
I was the Pied Piper in 5th grade.
I play mallet stuff in the front.
I played
Close enough. It's stop.
wild times when I was a kid.
Oh yeah, what you play flute? That's where you go.
I didn't know. I was awful. And I hated every second of it, so I transferred.
Okay, we don't have to know. All right. So, Everything we've been doing so far has been at standard conditions. That's what the little degree symbol means. Standard conditions. But what if we're not at standard conditions? Calculating E cell at non-standard conditions. We're going to use what's called the Nernst equation. This is given. It was on the equation sheet. They took it off the equation sheet for a while. Now it's back on the equation sheet. Now we're never going to have to really plug in on the AP test to the Nernst equation. I'm going to show you how to do it, and we're going to do it because you need to do it for college. But it's just plug and chug into a formula. But we need to be able to explain what happens at non-standard conditions, because they do ask those questions, which is why they put the Nernst equation back on. Okay, so the Nernst equation is simply this. E cell at non-standard conditions is going to equal the E cell at standard conditions. That's what this is E red minus E ox, minus 0.0591 over N times the log of Q. Oh man, Q.
That's the worst learned.
Why did they choose Q?
Because that's a question. Nobody knows what it is.
As like the opposite, not opposite, but the one that goes with K. Is this?
That the same Q.
That's what they
Now,
usually charge.
the reason why we can't use K is because a battery can't be at equilibrium. If a battery's at equilibrium, what do we say about the battery?
Broken.
Not broken, it's
Dead.
dead. Oh, my battery is dead, right? My car battery is dead. My battery in my calculator, it's dead. My battery in my flashlight, it's dead, right? That means that my reaction has gone to equilibrium, and so there's no more transfer of electrons. There's no net push that's going equally in both directions. So Q though, Q is still going to equal concentration of products raised to some power X over the concentration of reactants raised to some other, whatever remember it's coefficients, whatever the coefficients are, products over reactants. That's the biggest thing that you have to understand. Now, if it's standard conditions, 1 molar and 1 molar, doesn't matter what X and Y are, right? 1 to any power is still going to be 1. So if my products and reactants are both at 1 molar, Q is going to equal 1. Well, what's the log of Q? What's the log of 1? 0. So this whole term cancels out. E cell, if we're at standard conditions. But if I start with way more reactants than I have products, what does that mean about my value of Q? Greater than or less than 1? If I have a whole bunch of reactants greater than 1 molar, 3 molar, 5 molar, it's less than 1, right? What does that mean about the log of Q? Positive or negative? Negative. Decimals, the log of a decimal is negative. The log of a number greater than 1 is positive. Right? The log of a decimal is negative. The log of a number greater than 1 is positive. That's the big thing right here. Because if we have more reactants, a greater concentration of reactants than I do products, then when I take the log of Q, it's going to be a negative number. So then a minus, I'm going to add to that E cell, and it's going to increase the voltage of my battery. On the other hand, what happens to a battery over time? When the reaction is going left to right, left to right, left to right, So what's happening to the amount of reactants and the amount of products? Reactants are decreasing, products are increasing. So eventually, products are, if we started with 1 molar and 1 molar, where reactants is going down, products is going up, now we're a number greater than 1, a positive log of Q is positive, so an E cell minus a positive, what happens to my cell potential? It goes down and down and down until eventually it's dead. Okay? So the Nernst equation can help us explain what goes on. So when we go back, I just closed it out, doggone it. To our mock exam. You guys need a mental break anyway. Hey, we're pushing through. Hey, our next couple of weeks are very skimpy, so we gotta take advantage.
JJ, go. What? Right after? Follow me. No, you follow them. I think it was Jake. No. Hey. To get up in front of you, don't listen to anyone else. All after school.
Okay.
Activities are canceled.
So, okay, so here's our equation. Okay, I'll break this over. Totally refreshed now. Okay, so here's our equation. We calculated E cell. We calculated it to be 1.135. Okay, and so that was at standard conditions. We calculated delta G, but now it says when the concentration of NADH increases while the concentration of NAD plus decreases, will the electrochemical potential increase, decrease, or remain the same, and justify your answer? This one was like nobody got it. Okay? Now part of the reason was most like us hadn't gotten to electrochemistry yet. Okay? But this is very hard to explain because of this whole Q thing. All right, so I want us to be able to explain this one, okay, fully. So, again, here, the NADH is decreasing, and the NAD plus is increasing. And that would, no, it's the opposite. The NADH, this is increasing, and this is decreasing. So if I have more reactants and less products, more reactants and less products. I still want to make sure I'm saying this right. Okay? Now, hey, the NADH is on the left. Remember that. NADH is on the left. The NADH increases. And so the reactants increase, products decrease. All right? So we're starting with more reactants. What's that going to do to my Q? If we started at E cell, 1 and 1, this increases, this decreases, what does that mean about my value of Q? Greater or less than 1?
Less than 1.
Less than 1. Therefore, the log of Q will be negative, and according to the Nernst equation, a negative Q will cause an increase in E cell. A negative of log of that when Q is less than 1, the log of Q will be negative. causing E cell to be greater than. Okay? Now, I like to explain it just like this. When I was, okay, so this was on our mock exam. This is the question that I was one of the questions I was in charge of. And in preparing for that, I went and watched the guy that, I think it was Danny, who explained it last year. And he went through and in this long explanation and put in fake numbers. Okay, that you started at 1 and 1, but then a half a mole reacted, so you went to the reactants went to 1.5 and the products were at 0.5, and plug it in and just went through and showed the math. I don't think you need to do that. You can just say that if reactants increase and products decrease from standard conditions, Q will be less than 1, which makes the log of Q negative. That will cause, according to the Nernst equation, that will cause E cell to be greater. That would be your explanation, your justification. Okay? It's all about Q when they ask that question. Chapter 20. Quit acting like y'all are tired. I'm the one doing all the work.
You're processing a lot.
Yeah. He did this for 20 years. This is our first one.
He's not wrong.
Oh. Oh, my bad. I'm sorry.
Okay. No. Okay. A voltaic cell is constructed that uses the following reaction and operates at 298. So what is the EMF? EMF stands for electromotive force. That's your cell potential. EMF means electromotive force. It's the exact same thing as your cell potential. That's E cell is equal to E red minus E ox. Electromotive force. What's the force pushing the electrons through the wire? So we use the back of the book. We have to have the E cell to get this. So I go to the back of the book and I say my E cell at standard conditions is going to equal E red minus E ox. And we have, what do we have? We have zinc going to zinc 2 plus and nickel 2 plus. So zinc is negative 0.763. Zinc solid. E is equal to negative 0.763. I just said it. And then the nickel, 2 plus 2 electrons. We get this in the back of the book. It's given. The nickel, negative 0.28. Okay? So how do I find E cell? Which one is going to be oxidized? Which one's going to be reduced? Negative 0.28 is more positive than negative 0.763. So the first thing is, what would my half reaction be? Kind of does it tell you? Yeah. Okay. So notice the nickel's getting reduced and the zinc's getting oxidized. So we already knew that that was going to be based on the equation. So my E cell is negative 0.28 minus negative 0.763. So that equals what? Was that gonna be 48, 483?
That's the worst calculator I've ever seen.
483?
Oh crap. Dude, wait, this calculator sucks.
Oh,
Right? We always want to set it up to be positive.
0.483. Okay.
Yeah.
I just did it in my head. Okay, mental math, it's way faster.
Well done.
Okay, now, that's standard conditions. That's 1 molar, 1 molar. Everything's 1 molar, 25 degrees Celsius, 1 atmosphere of pressure. Okay? Now, what is the EMF of this cell when, what is the EMF of this cell when nickel is 3 molar and the zinc is 0.1 molar? Well, first off, the nickel is 3 molar, the zinc is now down to 0.1 molar. So what does that mean about my Q? Products over reactants.
The negative or the log will be.
Well, first off, Q, is it gonna be less than or greater than 1? Less than 1, therefore the log of Q is gonna be negative. So what do we know qualitatively about my E cell already? It's gonna be greater than that. It's gonna go up, right? That's positive is what you meant, but that means the change in the E cell is gonna be positive. The battery's gonna be stronger. You start off with more stuff than what you need. So, but to calculate that, E cell is gonna equal my 0.483 minus 0.0591. What's N gonna be in this one? Okay, somebody over here, what'd she say? What's N gonna be? 2. Okay, because we're going from 0 to +2, and we're going from +2 to 0. 2 electrons gained and lost. So N is going to equal 2 times my log of, again, remember, solids are not in my equilibrium expression, only aqueous. So it's going to be my zinc, which is 0.1, and they're all coefficients of 1 over my 3. So, somebody on a calculator? Okay, did somebody else get that, 0.497?
No.
I got 0.9.
I got 0.526.
Yes, that's what I got.
Yes.
But she got 0.497.
Oh.
Yeah, what's your? Wait, what's your?
I got 0.526.
Yeah, it's 0.526. That's what it is.
Okay, 0.1 divided by 3 equals 0.033. I want to take the log of second function answer equals negative times 0.0591 equals divided by 2 equals. So that's my whole term. 0.483 minus second function answer. I get 0.527.
Yep.
Yeah.
Like, honestly, I wouldn't tell people.
Now, okay, so listen. You don't have to calculate, you have to do that calculation on the AP test. It's a simple calculation, really, because the formula is given to you. As long as you know what Q is, they give you the values, you just plug it into Q. They took it off the AP test because they felt it was just plugging into a formula that didn't really measure anything.
That's That's what we like.
That's what I need.
Okay, but what they didn't take off is the explanation of why does the cell potential increase. Okay, the cell potential increases because Q now is much less than K, so in order to reach equilibrium, the reaction must proceed more towards the right, increasing the cell potential.
Yeah, I also found chapstick on it. On this ear over here. Free chapstick.
Yeah, I don't know if I'd use somebody else's chapstick without knowing whose it was, but
That's
They
just
might
cut,
have-
just cut off.
it might have cooties.
Just cut off the tip.
Okay, now listen, wait, I gotta give, don't act like we're done, we got 5 minutes left.
No, yeah,
Oh, no, no, that's right, I was thinking this at the end of the day. Wait a second, let me just re-say, I was supposed to re-say what I said.
Oh, that's okay, we can save it for.
What did I say?
Cell potential increases because Q is less than K.
Q is less than K, therefore the reaction must proceed towards the right at a greater rate to reach equilibrium. But my better explanation is with the Nernst equation. I think that's an easier mathematical explanation is the Nernst equation versus Q. Tomorrow I'll show you just the scoring rubric on that on our
Oh, man.
mock exam.
Are we?
All right.
Oh, man.
Can't believe